Hi everyone. Today I'll be talking about how data science and big data analytics are transforming healthcare, particularly in predicting diseases. This topic is really exciting because it combines two cutting edge fields: data science, which helps us make sense of complex information, and big data analytics, which processes massive data sets that traditional methods can't handle. Together, they're helping us better understand health trends, improve diagnosis, and even prevent diseases before they occur. Let's dive in and explore how these tools are shaping the future of healthcare. So, let's start with the basics. What exactly is data science and big data analytics? Data science is all about using statistics, programming, and domain expertise to extract meaningful insights from data. It's the process of turning raw numbers into something useful. On the other hand, big data analytics focuses on processing and analyzing huge data sets that are too complex for traditional tools. These two fields work hand in hand to tackle big questions like predicting diseases by uncovering patterns and trends that might not be obvious. And why is disease prediction so important? Early diagnosis can save lives. For example, catching cancer or heart disease early often means more treatment options and better outcomes. Disease prediction Disease prediction also helps with prevention. If we know that someone is at risk, we can take steps to stop a disease before it starts. Beyond individuals, it benefits the entire healthcare system by guiding resource allocation and supporting public health efforts. Together, data science and big data analytics are paving the way for smarter and more efficient healthcare. Now, let's talk about the role of big data in healthcare. The healthcare industry generates an incredible amount of data, from electronic health records to genomic information and even data collected by wearable devices like fitness trackers. This creates a massive pool of information, but it's not useful unless we can organize and analyze it. That's where big data analytics comes in. By processing and structuring these data sets, we can make sense of the information and use it to identify patterns that can help predict diseases. For example, analyzing genomic data can reveal genetic markers linked to conditions like diabetes or heart disease. Beyond just predicting diseases, big data analytics supports real-time decision-making. This means doctors and healthcare providers can act faster and more accurately, whether it's diagnosing a patient or responding to an emerging health crisis. Big data is truly revolutionizing the way we approach healthcare. Now let's dive into the techniques and applications of disease prediction using data science and big data analytics. First, the techniques. Machine learning plays a huge role here. It uses algorithms like neural networks or decision trees to analyze data and make predictions. For example, a machine learning model can learn to identify patterns in genomic data that indicate a risk for certain diseases. Alongside this, statistical methods help to uncover correlations that might not immediately be obvious. As for applications, the possibilities are incredible. One example is using genomic data to predict the likelihood of developing cancer, allowing for earlier and more effective interventions. Another is monitoring diabetes with data collected from wearable devices like blood sugar levels or physical activity. Big data analytics also helps track cardiovascular health trends in real time, enabling healthcare providers to take quick action when needed. These applications show how data science and data analytics are transforming disease prediction into a powerful tool for better healthcare. Let's talk about the advantages of using big data analytics in healthcare, specifically for disease prediction. Um, First, scalability. Big data analytics is built to handle massive data sets, something that traditional methods just can't do. This means we can analyze information from millions of patients at once, providing insights on a scale that was previously unimaginable. Second, uncovering patterns. By analyzing these large data sets, big data analytics can identify subtle trends that and correlations that might go unnoticed otherwise. For example, it can find genetic markers or lifestyle factors that increase disease risk, helping us predict health issues before they even arise. And third, real-time decision making. This is a game changer for healthcare. With big data, healthcare providers can get instant insights that guide their decisions, whether it's flagging an abnormality in a patient's test results or responding to a public health crisis. These insights can save lives. So scalability, pattern recognition, and real-time action, these are the key advantages that make big data analytics so impactful for disease prediction. And of course, like any powerful tool, using big data analytics in healthcare comes with its challenges and limitations. Let's break these down into two categories: technical challenges and ethical concerns. First, the technical challenges. One major issue is data integration. Healthcare data comes from so many sources like genomic databases, electronic health records, and wearable devices, and combining all that into a unified system is incredibly complex. On top of that, analyzing these massive data sets requires a lot of computational power, which can be expensive and resource intensive. Then there are also the ethical concerns, the biggest one being patient privacy. With all this data being collected and shared, there's always a risk of breaches or misuse. And another issue is potential bias in the data sets themselves. If the data isn't representative of all populations, then the predictions could just end up being inaccurate or unfair to certain groups. But these challenges don't mean we should stop using big data analytics in healthcare, but they do remind us that we need to approach it thoughtfully and responsibly, addressing these issues as we move forward. Now let's look at the future potential of data or big data analytics in healthcare. This technology is already transforming how we predict and treat diseases, but its possibilities go even further. One exciting area is integration of artificial intelligence with the real-time health monitoring. Imagine wearable devices not only tracking your health data, but also using AI to predict potential issues and alert you or your doctor immediately. This could prevent conditions like heart attacks or strokes before they happen. Another opportunity is using global health datasets to prepare for and respond to pandemics. By analyzing trends across countries and populations, big data can help us detect outbreaks early and allocate resources when they're needed the most. Lastly, there's precision medicine. This means creating treatments that are tailored to an individual's unique genetic makeup, lifestyle, and environment. Big data analytics will allow us to go beyond one size fits all approach and develop therapies that are highly effective for each individual person. The future of big data in healthcare is incredibly promising, and its potential to save lives and improve global health outcomes is truly inspiring. To wrap things up, let's visit the key takeaways. Big data analytics and data science are revolutionizing healthcare, particularly in the field of disease prediction. By processing massive data sets, uncovering patterns, and enabling real time decision making, these tools are improving early diagnosis and treatment options and overall patient outcomes. At the same time, it's important to remember the challenges, like ensuring data privacy, avoiding bias, and managing the technical complexities of integrating and analyzing large data sets. Addressing these challenges responsibly will be key to unlocking the full potential of these technologies. Looking ahead, the future is bright. Innovations like real-time health monitoring, global disease tracking, and personalized medicine promise to take healthcare to the next level. Thank you for listening, and I hope this presentation has given you a new perspective on how data science and big data analytics are shaping the future of healthcare. Thank you.